our primary needs.
Yes.
It means which is in common with animals.
Yeah.
Like eating, for example, if I want a fruit, I have a fruit, I find it beautiful, and it's sweet to my to my stomach and my taste.
Yeah.
It means it's good for me, and I know it. It means I see that everything's sweet for me around, and especially also the secondary needs. And when I say the secondary needs. Needs.
Okay, sorry,
like, for example, lotions. The animal, they will not use it. Petrol, if we want to go to travel fast, we find petrol and we find metals, you know. We found that the physics is organized to make our way of life easier.
Okay, I think I see what you're saying.
For example, everything.
Okay,
for example,
but there's lots of things that are difficult for us.
For example,
right?
no. For example, the density of the air.
The what?
The density, the air density. Air density.
The air density.
The air density permit us.
For us here.
To travel with fly.
Right.
So we find that everything's sweet for us.
Okay, but are you not being a little bit selective?
Not selective.
Okay, can I say why I think you're being selective? You're right, there are lots of things that are nice for us. There are lots of things that are bad for us.
Yeah.
Okay? Lots of bacteria come and kill us.
No.
Right? Lots of viruses come and kill us. Asteroids come and kill us. The fact that the Earth, most of the surface of the Earth is not inhabitable for humans.
Okay.
So we've evolved to the conditions of the Earth. No surprise. Where else would we evolve to? Right? If you look at, like, there's so many things that are trying to kill us. Gamma ray bursts could go off and wipe us out tomorrow.
Okay.
You know, what if you know, a big star exploded and wiped us out with gamma rays? You know, that can happen tomorrow.
But
right? An asteroid could fall on our head tomorrow.
I understand.
Right? You're being selective in the things.
Of course, no. Because even if you see, no. If your objective, that even if you see the things which are bad for us, like asteroids, we find that something that has been put to prevent against.
What has been put to prevent an asteroid?
Microbes. Okay. You talk about bacteria.
They're not going to stop an asteroid falling on your head.
Okay. An asteroid. You said asteroid.
Yeah. What if a gamma ray explodes?
Okay,
gamma ray burst happens near us?
Okay,
what's going to protect us?
Okay, tell me that. We have our, for the radiation from the sun, we have the core, the Earth core, you know, in metals.
That's not going to protect you from a gamma ray burst, is it?
From a?
Gamma ray burst.
What is it?
Okay, gamma ray burst, when certain stars explode...
Okay, you mean the big rocks. Big rocks come in Earth.
Yeah.
We have our atmosphere.
That's not going to protect you from a gamma ray burst.
Look, you haven't. This is strange because we haven't received any asteroid like this.
Really? What wiped out the dinosaurs?
Oh, you're talking about the dinosaurs, but you're supposed to be created after.
Yes, but they happen every tens of millions of years.
Moreover,
we get hit.
No, look, because you don't. This is not. If your object, you see that when the dinosaur, we couldn't survive with the dinosaur, and we found out that something happened. It could be volcano, or it could be that thing. Sorry, it could be that thing.
Right.
But just after, nothing happens. Nothing.
Well, nothing's happened yet. We have only been here for like 100,000 years or 200,000 years.
In my hypothesis, this is just a conjecture.
No, it's not just a hypothesis. We have evidence. This is what happens.
This is
continually.
Hang
on. Let me say something.
Tell me.
This is what happens continually in the universe. Okay, this is not a hypothesis. We have very, very firm evidence that there are things out there that are basically can wipe us out like that.
So why
now we've only been around. The Earth has been here for about 4.5 billion years. Modern humans have only been around for like 100,000 or 200,000 years, right? So obviously we haven't been wiped out yet because we just got here.
We don't know.
We just got here.
We found that
right. We just got here, so of course we haven't been wiped out yet. But that doesn't mean we can't get wiped out tomorrow. Okay? And there are plenty of things in the universe that could wipe us out tomorrow, easily.
It never happened.
Right? What do you mean it never happened? It did happen. How do you think the dinosaurs got wiped out?
But we weren't there.
But why did we need to have been there?
You seem to need something which is perfect, it means nothing could happen to you.
No. Your argument is that the Earth is perfectly construed for us. The universe is construed for us.
My argument is that everything we see around fit to us.
We have evolved to our environment, of course we have. We've evolved to it.
It doesn't mean that you cannot be killed by something. It doesn't mean, entail, that you cannot be killed by something.
So what is the argument then? You're saying...
I'm just telling you that what we observe fit to us. It's organized for us. Even if we have some dangerous things, we can't be protected by this.
We can't be protected from a gamma ray burst. That's not correct.
But the problem is just putting theory of like...
It's not just a theory. We know gamma ray bursts happen. We know there are these stars out there. It could go off tomorrow.
But the thing is, you're just talking about something which happened in the universe and never happened in our Earth.
It did. You're wrong.
No, it happened, but before us.
Yes. So why can't it happen tomorrow? Okay, let's put it this way.
That's
not working, is it?
Sorry?
Not working.
Maybe.
He didn't want to be
I don't want
recorded.
to be
He doesn't want to be filmed.
Yeah, it's pointing down at the floor, don't worry.
Okay, listen.
So just my answer to that, I didn't say that we are protected from everything and we will never die. I didn't say that.
Obviously, we are alive now.
Like, we are alive. I didn't say that we cannot be killed by anything. I just said to you that it's sweet to us. For example, bacteria, we are protected by us.
We are now in the age of antibiotics.
No,
we weren't before.
Okay.
You want to know what happened to people that got a bacterial infection 100 years ago?
Okay,
Do you want to know what happened? They died. Like if you got a little bacterial infection 100 years ago, you die.
Okay.
So this idea that we're protected is, I'm sorry, it's wrong.
No.
Again.
Exactly.
No, I'm just
look at gonorrhea. We can't protect from
You don't have immune system.
But it's not perfect, is it?
No, but you find the thing in the earth to cure you. You have to look at it.
It doesn't cure you from everything, though, does it?
You find it. For cancer, you find it. For cancer, you find it.
Your immune system just cures cancer, does it?
Huh?
Your immune system just automatically cures cancer. No one ever dies of cancer.
No,
Loads of people die of cancer, right? The immune system is not that good. It isn't.
I'm just telling you that your immune system, it cannot destroy everything, any bacteria, but you have to look for the thing which will help your immune system to destroy the bacteria. And the good thing is that you find it in the nature. Everything you want to, you need.
Yeah, okay, so now you said everything. Everything you need, you find, right? That's what you're saying.
No, just
okay, and that's false. That is just not true. There are plenty of things that we know can kill us that we don't have any defense for.
Oh, well, let me tell me.
I just gave you an example, a gamma ray burst. A gamma ray burst goes off, nearby gamma ray burst goes off, we are dead. We will be wiped out by the radiation.
Okay,
there's no way the Earth's atmosphere will stand a chance.
If the Earth is destroyed, if the Earth explodes, we cannot be protected from it. I didn't say that we...
You said everything.
Not talking about this, I'm not talking about this or big, huge things like this. But the thing is our way of life.
But why aren't you?
Huh?
Okay, let me make this point.
I'm not talking about death. I'm not talking about...
Look. Let's make this point. Human beings have evolved to suit the environment that we're in. Right? So it's no surprise.
That's a theory. I just told you.
That's not, what do you mean, theory?
Theory. I'm just telling you that there's different level in the evolution. Theory.
Do you agree that humans evolved to suit the environment that we live in?
No, that's a theory that from a cell we evolved. Okay.
You don't accept that humans evolved?
No, I believe that creatures has been created, and every creatures evolved in a certain way.
Okay, hang on. Because you were saying that there was science behind what you were saying, but now you're denying basic science.
No, this is a theory, and you can criticize
What's a theory in science? Tell me.
Theory, it's a conjecture.
No, you clearly don't understand what the word theory means in science. Okay, the word theory in science does not mean conjecture. That's false. Okay, in science, theory means something very different to that. Okay, a theory. So that you're thinking of colloquial language. In colloquial language, theory means I got a guess. You know, my guess is. Okay. But in science, we don't use the word theory in that way. In science, theory means an explanatory framework. Okay, something an idea that can explain many facts in one organizing hypothesis and makes predictions for future hypotheses, future data, sorry. Okay, so the theory of evolution, both. Okay, the theory of evolution is very well confirmed by the data. Okay. Have you studied any evolutionary?
Tell me.
Okay, I'll give you an example. Right? Have you heard of? You know that you've got a number of. So you know you have centromeres and cells and telomeres. Are you familiar with that?
Cells, yeah.
Centromeres and telomeres in your chromosomes. Sorry.
Okay.
You know you have about 24 chromosomes.
24, 26, yeah.
24 chromosomes,
yeah,
right?
okay.
Okay. You know that we have one less chromosomes than other apes. Are you familiar with that?
One, excuse me?
One less chromosome than other apes.
No, I don't think he knows what you're talking about.
Well, I should ask him.
Yeah,
sorry.
yeah.
No, tell me.
Okay, all right.
Yeah.
So we have one less chromosome. Okay. Now, on chromosomes, you have things called centromeres, which are in the middle of chromosomes, and you have telomeres, which are on the end of chromosomes. Okay. Now, evolutionary theory predicts that we can't just delete a whole chromosome. There's too much important genetic information on the chromosome. Okay. So therefore, it predicts that the chromosomes fuse together, and that's why we have one less. Okay, then you won't lose any important genetic information. The organism won't die. Okay. Now, if that's true, you can look through the genome and try and map it, and you can see that there should be a chromosome. Where, so if you think of it this way, right? Imagine my arm is the chromosome, and let's take my elbow is the middle. Okay, and my fist is the end. So at the end, you have these things called telomeres. Okay. So if the chromosomes fuse together, the telomeres are on the end. They fuse together. Where are the telomeres?
The extremes, no?
No, where are the telomeres? Where are they? Where? Like this, what word would you use to describe where they are?
Tell me.
They're in the middle.
Okay.
Okay. So if they're in, so where would the centromeres be now? They used to be in the middle. Where would they be now?
In the extreme.
No, they'll be like halfway between the edge and the middle. Okay. So we can go through the genome, okay, and we can see if there's a telomere fusion point. Okay, and guess what? That's what we find. And we find that it matches the extra chromosome that we find on other apes. So this is a prediction of evolutionary theory, yeah? And you can look up the paper. I'll show it to you, okay? Telomere fusion, okay?
But look, this.
Okay.
The mechanisms. Look, the mechanism. It doesn't prove the whole theory, the evolution.
Well,
theory.
if you have a theory that makes a number of predictions, that's not the only prediction. I can give you a whole book full of them, quite frankly.
No.
And all those predictions are exactly when we go and look at the data. I mean, let me show you one thing, right? When they sequenced the chimp genome, they looked at all these predictions, and this is the paper. Mike's anniversary card. Don't want to lose that. Okay, I'll be in trouble there. Okay, so this is. Let's find it.
But how does it confirm? It means the whole theory. You're just showing me some points. You
okay,
don't,
well, obviously I can only
theory.
do one thing at a time, right? The whole theory is confirmed because multiple of these predictions are exactly what the data tells us. And this was the sequence. This was the gene. This is in Nature, which is probably the most prestigious scientific journal in the world, or certainly top few.
Okay.
And this was the chimpanzee sequence consortium. So there was all the top universities in the world worked on this, and when they got the draft chimpanzee genome and compared it to the human genome, there are all these predictions that evolutionary theory makes, and they can then analyze the genome and see, does it confirm what evolutionary theory predicts? And you can see what they said. More than a century ago, Darwin and Huxley posited that humans share recent common ancestors with African great apes. Modern molecular studies have spectacularly confirmed this prediction. Okay? I can give you...
No, they said it.
Yes, I know.
Who was writing this?
I just told you. Didn't I just tell you that?
No, you
it's
just
the
said,
chimpanzee genome consortium.
Look.
It's all
you
the
just showed me an article saying it has been confirmed.
Now I also explained to you.
All across.
I also explained to you.
They are not science. You know that science not.
That's not science.
Just human.
How is that not
There's
science?
a lot of scientists who just reject this theory.
No, there isn't.
They do not confirm it.
I'm sorry, but that's not correct. Okay, that is not correct.
Okay.
Not in reputable journals, not in serious scientific journals that have high impact factors. You don't find that.
I told you this is the whole theory. This is where you just showed me an article saying yes, it confirmed the evolution. I told you that I believe in the evolution, but not in the whole theory telling that we were cells and something happened and we become a lizard, and something happened and we became something others. This is just, it means randomly. This is the theory.
No. You've misunderstood the theory. The theory does not say it's all random. That's false. You've misunderstood it. Evolutionary theory has a random component, which is genetic mutation, but it has a non-random component, which is selection. Okay? So selection is not random.
No.
And therefore, to say that evolutionary is random is to mischaracterize what the theory says.
So what you're telling me now is that, for example, for one protein, do you know the probability to have? Sorry, I don't want to be fair. To have one admissible protein. What is the probability to have one admissible protein? What is it?
I don't understand your question, I'm afraid. Admissible protein? I don't
It means which works, a protein which works. One protein which works. What is the probability?
I don't know the probability.
Okay, the probability is 1. I don't know in English how to say it. 1 divided by billion of billion, more than the particle in the universe. So this is absurd to believe. So you believe? Okay. So you believe that there were lots of mutation, and from the cells we had several mutations. According to the probabilities, we had billion of billion of billion of billion of billion, more than the particle.
How do you derive that probability?
The probability has been this probability.
Yeah. How do you derive that?
Peptide bonds. Do you know the construction of proteins? Peptide bonds. Okay.
Yeah.
We have one.
Okay. If I showed you an experiment that proved that you can get function from random assemblies of proteins.
No, I'm just telling you the theory.
Would you change your mind?
No. The theory for one protein.
But, no one takes that calculation seriously. No one does. Okay.
Okay.
No,
please.
You're getting that from a creationist website. You're not getting it from serious scientific journals.
Really?
Yeah.
Okay, make your research.
Tell me. Give me a serious scientific journal that thinks that's a reasonable probability.
I want just to explain you. I just told you that a protein is composed by an average 150 peptide bonds. Do you accept this?
Okay.
Okay. We have one chance. 1 divided by 2. How do you say in chance? 1 divided by 2.
I don't know what you're saying, so I can't tell you.
One and a half. Sorry, it's just my English. It's just 1 out of 2. Just 1 divided by 2, the probability.
Okay, let me ask you a question.
Just for one peptide bond, if you just apply the probability, and this is mathematical, it is established.
Okay, but all mathematics is not established. All mathematics has assumptions. Okay, this is basic science. All mathematics has assumptions. If you're going to model the probability of anything, no. If you're going to model the probability of anything, you have to have physically realistic conditions. So you can't just say it's pure mass. No probability for anything that happens in nature is pure mass. It doesn't work that way. Okay? You have to model what is going on. Okay? Now, when evolution occurs, it's not purely probabilistic.
No, it's not purely.
It doesn't work that way.
I understand.
Therefore, you're not assuming that that fully formed proteins just appear like that. It doesn't work that way.
No.
There are selection effects.
Your theory is that they were random mutation, and only those who had the good features survived because they had it. And this is why you believe. This is what
why I believe is because there is lots of predictions that evolutionary theory makes that have been confirmed by experiment over and over and over again. Okay, you can look at any serious scientific journal and you can see a gazillion
empirical tests.
I just gave one. I'll give another one.
No, you showed me. No,
they are empirical
you
tests.
showed me an article telling that it confirmed the theory. That's it. You just in your iPad.
Okay, I'll show you another one.
But the thing is, how can you base something that's empirical can't really take it as an empirical as a fact.
Why is it not empirical?
Because no, you can't really take an empirical test as something to be fact, can you? Because
well, what do you mean by fact?
For example, if you take a number of species and then you take one out of those species and then you do a test on it, you can't take it based upon that and then count for the whole of the rest of the birds, for example.
No, but no one's doing that. What you're doing is when you're taking a theory and the theory makes a number of predictions for data, then you go and look through the data and the data comes back precisely what the theory says, then you have to take that theory seriously.
But it's just a theory,
can't just say
it's just a theory. There's a number of theories and it might change tomorrow. There's been so many theories throughout history.
No, but there haven't been so many theories that have been confirmed by enormous amounts of quantitative data.
Okay, but
that is not common.
The thing is, there's been so many theories out there that even if you're saying they've been tested out there, they change just like that. There might be another theory that come out tomorrow, and you might have a test that confirms it, but then somebody else will come with another theory and confirms it, and they contradict each other.
Okay, so of course anything might be true. The question is, what do we have evidence? You have to go with what evidence you have.
Problem,
okay.
Sorry,
you have to go with what evidence you have.
My problem is that you put everything together. You just confirm the mutation and the effect we can have in mutation, because mutation could be something God's used to add something to a species. We can use mutation. He could use mutation.
Of course, he could use anything he likes. He could have created the world yesterday.
I don't want to be fair.
He could have created the world yesterday.
No.
Right?
Just mutation is something which is not. You just put everything together. You confirm the whole part of the theory by just some facts which come from the mutation.
No, that's not correct. That's not correct.
Why?
That's not what happens. The theory makes a whole bunch of predictions, okay, in different fields, in different types of tests. And if all those tests, let me give you another one, right? Okay, you take a gene like a GULO gene, right? This is a deactivated gene, okay? What you find is that if you trace what the evolutionary theory predicts is take GULO gene, what it does is it metabolizes certain acids so that you can not die of scurvy. And we have that. If you don't eat fruits, you die of scurvy, right? Okay? Now we have that gene, but it's been deactivated, it doesn't work. So we have to eat fruits, otherwise we die of scurvy. Okay? So that contradicts what you said before, that everything's been made tinkered to us, because we've got this gene that's been deactivated. Now, what evolutionary theory predicts, you can do genome sequences and you can see if these genes are switched on or off, and that gene is switched off. Okay.
Okay, but how do you know that if it's switched on, it works, and it has this?
Because you
this
can do genetic manipulation on stuff.
In human.
There's CRISPR now. You can switch. You can do all kinds of. You can do rewriting of genes now with CRISPR. Are you familiar with CRISPR? CRISPR is allowing you to do this very new technology. It's allowing you to literally rewrite genes.
Okay, but how do you know that?
And you can have genetic switches, switch them on and off. They've done that with many experiments. You can take a genetic switch and switch it on or off.
Yeah, but
they've done that. That's experimentally
we have it.
verified.
But you think we have it?
But why is it switched off?
Okay, this is not.
No, but you said everything was sweet for us.
No,
that gene is essential for your survival if you don't have access to fruit, and it's switched off. Now you said everything was sweet for us. If everything was sweet for us, that gene would be switched on. So that disconfirms what you were saying.
No, it doesn't disconfirm.
Why not?
You think?
Karen. Well, I was trying to say, you said that about predictions. So the theory is a number of predictions, and they're confirmed by tests.
Yes.
But now you have different theories, right? So my question to you is, okay, you have different theories. Somebody might come with a different theory, and you might have a test that proves that theory, right?
Yeah.
But then you have somebody else that has a theory that contradicts that other theory with a test that proves that. Then how do you work out between? How do you distinguish between them?
Okay, I don't think your basic assumption is generally correct. If you have a theory that has made many predictions confirmed by experiment, I don't really know many cases.
There's many.
Go, give me some examples where a theory has made all kinds of precise predictions, and then another different theory makes completely different predictions, and they're both confirmed. That doesn't happen. Give me some examples.
There are so many theories, and
give me some examples.
There's always new theories that come about.
Give me some examples where that happens.
There's always so many theories. Even if today, you might have a theory now. Even it's been happening in the past, right? That you have a theory, somebody might have a theory, and then somebody will come up with another theory, and then it's just people go on the different opinions.
No, it's not like that. Okay, look, let's take a murder case, for example. Let's suppose I've got a theory that this guy over here is a killer, okay? Right? Thanks. I know, I'm sorry. Right, now, if my theory is true, then all of the evidence should point to him. Let's suppose we've got the murder weapon, and we've got fingerprints on the murder weapon, okay? Let's suppose there's DNA, okay? Let's suppose there's boot marks, okay? My theory will predict that if the fingerprints are found, it'll be his fingerprints. That if the boot marks are found, they'll match his shoes. Okay? That if I find DNA on the floor, it's going to be his DNA at the crime scene. Okay? Now you can tell me, oh well, yeah, but somebody could come on with something tomorrow. Now we're at the trial. You're asked to say, is he guilty or not?
Yeah,
okay? Now are you really trying to tell me, well, tomorrow someone might find completely different evidence, so I'm going to let him go? No,
instance,
all the evidence is pointing one way.
More than one fingerprint on the murder
just repeating
weapon.
this kind of
more than one DNA.
If there is, but you haven't given me an example of a theory. You have not given me one single example.
But let's just use this as an example, what you've just said now. If there's more than one fingerprint, there's more than one DNA.
Yeah.
My question is, how do you distinguish between the two? So we have to have a method of understanding.
Yes,
where does our
and we do have a method. We do have a method. It's called the scientific method.
No.
Which one? You're just repeating all the facts. You're just repeating. This has been established. This has been established. But where?
I've already told you.
What I'm trying to get at, my friend.
Read the scientific literature.
But there's different scientific methods. There's so many different. I believe in evolution. Yeah, I understand.
Okay, he doesn't.
I believe in evolution.
No.
Do you believe or do you know?
No.
Say again?
Do you believe or do you know evolution?
I believe in evolution because I know that there's evolution. There's certain things that evolve.
Believing and knowing is two different things.
There's certain things that evolve. Do you know what I mean? I understand that. That's my personal belief, right? I understand that. But the thing is, what I'm trying to say is that I cannot base everything that. Okay, I know that there's evolution, but I cannot base that from the universe. It evolved into something, or it came from.
You're saying the universe doesn't evolve?
I'm saying it does, but I'm just saying that's not the start, the beginning of the universe. How did the universe come about?
That's a good question.
But the thing is, many scientific. If you look at the scientific method, there are many different theories. Now
well, that's a good question.
Can I just finish? You might have one scientific method, and another person has a different scientific method.
Okay, no.
Which is a contradiction to itself, because which one do I go by? That's confusing. Right?
I disagree. Can I respond to that about the beginning of the universe? Okay, it's certainly true that we don't know how the universe began. Okay, and there are competing theories for how the universe began. Okay, now there were also competing theories for how the universe evolved, but those competing theories have been narrowed down. We know that the universe came from a Big Bang. The competing theories that said there was no type of Big Bang expansion were whittled away because the evidence clearly, with multiple independent lines of evidence, showed us that there was a Big Bang. Now, what happened before the Big Bang?
To be honest, to my friend.
Sorry?
I don't know them.
Well, I can explain to you.
That knowledge.
Okay, well, I can explain to you how it works.
You know why? Because the thing is.
No, but let me explain to you how it's different.
I understand that there's more than one theory. There's more than one theory within the scientific method, within the scientific world. And what I'm trying to get at is that in terms of the beginning of the universe, that I know that the universe had to start from somewhere.
Well, it could have been eternal. It could have been eternal.
But the thing is, how? Okay, if something's eternal, it has to be start something. You can't just have something come out of nothing.
If it's eternal, it's not coming out of nothing.
Even if it's eternal, then how did it? You have to understand that.
Jamaicans, yeah, that's a Jamaican fucking drum.
Okay.
Bill, you right, baby?
What I'm trying to say, is that something that's eternal, it has to have a beginning, isn't it?
No, if it's eternal, it doesn't have a beginning.
Everything has to have a beginning that's been created. Do you understand that the world has been created?
No.
Where did evolution come from then?
Created?
I don't.
It's the time and the date of creation.
Is it created? Okay, time. Yeah, it's subjected by time and space, isn't it?
Give me the date of the second that sun was.
We don't know. Nobody knows. No, because you know why? Because
exactly. No one knows.
Sorry, my friend.
If you don't know, just say you don't know.
No. I've just said I don't know the time and the date when the universe was created.
Why would you say it was created?
Because I know, because everything has a beginning, right?
Yeah, but time and dated.
Time and dated.
Hang on, how do you know that?
No,
how do you say everything has a beginning?
Scientific fact.
That's a
No.
Where did you get that from?
No, theories. Established that the universe was in expansion. So it has a beginning from the beginning. No?
No, that's incorrect.
Oh, really?
Yeah,
So?
really.
So,
where do you get that from?
so where do you,
No,
so,
an
so where was the
expansion. So
universe?
at the beginning, something happened. It has a beginning. And
The beginning. Okay.
What proof
Okay.
have
No.
you got?
Hang on. I think you're misunderstanding the science.
tell me.
You're misunderstanding the science. The Big Bang, right? We have very good evidence the universe is expanding. Okay. There's no debate about that.
Okay.
It expanded from an extremely hot, dense state.
Okay.
Okay. Now there are theorems proved by Roger Penrose and Stephen Hawking, and they showed that the Big Bang was the beginning of space-time. Okay. So the universe had a beginning from the Big Bang. However, those theorems have assumptions. Like I said, all physical theories must have physical assumptions. Okay. Now, the physical assumptions behind those theories are now no longer taken seriously, even by Penrose and Hawking and Bruce. Okay. I'll give you what those assumptions are, so you can understand. First assumption: gravity is always attractive. That's the first assumption in the Penrose-Hawking theory. Okay. But in 1998, we found the universe is accelerating in its expansion. Okay?
Yeah.
Now that means gravity is not always attractive. That's a repulsive gravitational force. Similarly, we have evidence that the universe underwent inflation. And that's also a repulsive gravitational force. Okay, I'm trying to educate you, right? So that shows you that the assumption that the Big Bang was the beginning of the universe is flawed. Because that assumption that gravity is always attractive has now been undermined.
So you tell me that there's diversion amongst the scientists.
I don't think there is much diversion. Most cosmologists agree today the Big Bang was not necessarily the beginning of the universe.
Okay, but but you believe? Do you agree that because it's in expansion, at the beginning it wasn't like this? It means that space-time wasn't. It means was the beginning of before.
There could have been.
There's no start for you. It is in expansion, but there's no start.
What I'm saying is that the theorems that said the universe had to begin at the Big Bang are no longer considered valid. Okay? Therefore, so let me give you another assumption of theory, and we can try and understand a bit better. Okay? Another assumption of theory is that general relativity, Einstein's theory of gravity, describes the large-scale behavior of the cosmos. Now that's true in almost all cases. However, at the Big Bang, the entire observable universe would be, smaller than a subatomic particle. Now, in that case, we need to include something called quantum mechanics, which is the science that describes subatomic particles. And general relativity does not include quantum mechanics. So what most cosmologists today agree is that you need to modify Einstein's equations so that they include quantum effects. Okay? But when you do that, what you find is the universe existed before the Big Bang. Okay, now we don't necessarily...
Is that a proof?
No, it's not a proof. What I'm saying is...
Okay, you just talked about conjecture theory.
No, it's not just theory. You have to understand what we're saying. The theory that said the universe had a beginning, right, had these assumptions.
Okay, I understand.
Okay?
These assumptions,
now we know those assumptions.
But
now, so we know what we need to do. We need...
So they just say, we don't know. Is that true?
Well, it's not just that, as I said. What we do think we understand is that we probably need a quantum theory of gravity to describe the Big Bang itself and what happened before the Big Bang. Okay? Now, what has been... We don't have a well-tested quantum theory of gravity. So these are, in your mind, just theories. But they're not just theories because they have to pass a number of rigorous theoretical tests. Can they calculate entropy of a black hole correctly? Things like this. Okay, so they're not just picked out of a hat. They're not just guesses. Now, what these theories have said is that the universe existed before the Big Bang and could be eternal into the past. Now, we don't know that that's the case. At the moment, we don't know which of these is correct.
So it's
okay. So you cannot. So here's the bias.
It wasn't my subject. It was his subject.
All right. But it allows me to give you the takeaway message.
I'm going to look at it. I haven't made my research, but I'm going to take it.
Fine. I'll show you how you can check this yourself. You don't have to take my word for it.
No, I'm going to check it.
Okay. So, all right. So the bottom line is the takeaway message is the Big Bang used to be thought of as the beginning of the universe. And there was nothing before the Big Bang. It doesn't make sense to ask what happened before the Big Bang. But that is no longer the view of cosmologists. And if you want to go and check that yourself,
what we know, something happened. The Big Bang.
Yes.
Okay.
We agree that.
So before it, science talked about. That's it. We know that something happened.
Yes.
Okay.
Agreed.
My point was about, I don't want to continue that subject, just about evolution.
Yeah, but you did say earlier on that you knew that God created space-time. You did say that. One of the very first things that's the first thing I interrupted you saying. And I say you can't say that. There's no justification for that.
No. I believe as a believer that.
Yeah, but you
God
said we have science.
No. I talked about the thing we have around. I think that you cannot deny that everything suits to us. Still telling
it depends what you mean by suits us. I agree that we have evolved to suit our environment. Of course we have. Right?
Okay.
Obviously we wouldn't be alive if we hadn't.
No, the problem
we have to observe that, don't we? We can't observe an environment that's not suited to us.
My problem with your assertion is that you take it upside down. You said we have evolved. Let me tell you, we have evolved in a certain way to be adapted to live in our environment. And you tell me and I ask you why do you believe this, and you tell me because we have scientific proof that evolution. Scientific assertion that the.
I didn't say assertion either. I said evidence.
Tell me, just
evidence.
In meaning. Okay, I'm just telling in meaning. I'm not quoting you.
Go on.
So you just tell me that. We know that the evolution theory is true, and I've just told you that the evolution theory it's broad. It's really broad. Mutation and evolution inside the same species, it's completely different. I believe in that. I believe that.
Yeah, but we're not debating that. Obviously.
Okay, I'm not debating in that species can evolve in a certain way, but making the relation between every creature in this world. This is the problem. And you said that there is 2 points. There is the random mutation and there is the selective, natural selective. And the problem is with the selection, natural selection. The natural selection. I told you with the probability for one protein, and you asked me where did I get that? And answer you that a protein. There is a scientist who made a conference and he talked about, but I didn't remember the name. But you can make your research. A protein.
I have researched.
Okay.
Yeah.
A protein is made by 150 peptide bonds, and if you have one chance for every peptide bond, 1 out of 2 chance, 1 out of 2 to have the good configuration. It means that you have several blocks. And you have 1 out of 2 chance to have the good configuration. If you multiply it just mathematical in terms of probability, you're 2, and in the exponent 150. And this is much more than the number of particles in the universe. This is much more. So according to you, according to the random mutation, you believe that we had several cases who died because the mutation wasn't the good one.
Okay, can I respond to that? Okay, so a mathematician once said to me, if you get a really unlikely event the first time you do an experiment, probably you're wrong about that it's an unlikely event. Okay?
Tell me.
Do you see the logic of that?
Can you repeat?
Okay, let me make the statement again. If you do an experiment, and the first time you do an experiment, you come up with a result that's incredibly improbable. What is the simplest explanation for why that happened? What do you think?
It's an error.
Sorry?
A mistake? An error?
An error where though? One possibility for the error is that you were wrong that it was improbable. Is that a fair thing to deduce?
No.
Well, that's not a fair thing to deduce.
No.
That you couldn't be wrong that it was improbable.
But I think we have the whole theory. We have the whole theory. We don't have just one explanation. We have the global phenomena. Okay,
but if the theory has been confirmed with multiple experiments and data, if just say hypothetically, X theory, won't talk about evolution, just some theory. Okay?
Tell me, just don't.
Let's make a general point. Make a general point.
Yeah.
If a theory has made a whole bunch of different predictions for data that we haven't yet found, then we go and look for that data, and every single bit of data that we found is exactly what the theory predicts. Okay?
Okay.
Would you not say that that is evidence that the theory is true?
No.
You wouldn't?
No, I just no.
Then nothing. What
This is
would
not-
convince you?
You're just pointing out one part of the theory.
No, I'm not. I'm talking
Okay.
general. How do we assess whether theories are true
Show
or
me.
false?
Okay. If your theory were true, you talk about evolution between species. Okay. We would have every step. Every step. You know, you have, for example, the man and the monkey. You will have every step between, but we don't have.
Okay, you're wrong. You're completely and utterly
Where?
wrong. Okay, first off, you're wrong that we should have every single different transitional form. We shouldn't, because fossils are extremely hard to form. So first off, you're wrong in your assumption that we should have all these different... Let me finish, okay? I've got to make some points, right? He doesn't want to be filmed, please. Yeah? Okay, so that assumption is false. Okay?
No, sorry, it's not. No.
Okay. So that assumption is false. Second false assumption, evolution doesn't say humans evolved from monkeys. It doesn't say that.
No,
Okay?
they said no. They said
doesn't
that
say that.
several mutations occurred on monkeys.
No.
I know.
No, it doesn't say that.
Okay.
Again, if you're going to criticize the theory, you should understand what the theory says.
Tell me. This is what I learned at school.
Okay, well then you had bad teachers, because evolution theory doesn't say that.
What is
Okay? What it says is that we had common ancestry with monkeys, not that we evolved from monkeys. They're different. Do you understand the difference?
Okay, so
Okay?
okay. No,
They're not the
what you mean.
same. We did not evolve from monkeys.
Okay, so
So
when
what
we
we
have
should
this
find-
evolution,
okay.
this famous picture from monkey evolved.
Yeah, but
like
that's not right. That picture's a stupid cartoon. It doesn't work that way.
this. Okay. So do you believe that
It's much more like a tree. Sorry, like a branching. It's more like a branching structure.
Okay.
Okay. It's not like a ladder.
Okay.
Okay. Now, what we should find though, is well, I think maybe you're alluding to, is that we should find fossil specimens that do show the evolution from the common ancestor, and we have loads and loads of them. I can name loads of them.
Tell me just one example.
Yeah, sure, fine. Let's look them up. There's loads of them.
This is because you believe in the Quran and his belief is more in rationale.
No, that's not. We're just
No, I'm
talking
trying to
about
understand.
science. I'm just criticizing the theory. He's just showing me a part. He's just showing me a part. I'm just telling him that he talk about mutation in the DNA. Okay, I don't have problem with that. But the problem is to generalize this fact to species, saying we have an ancestor and we evolved and we appeared. And I'm just asking you, what are the steps? Where are the steps?
Okay, well look, here we go. Well, you have to go on Wikipedia, it's all there. Right? Okay. I mean, have you gone on Wikipedia and looked for the hominid fossils?
No.
They're there. Oh, sorry, my internet's a bit slow. So, okay, here you can go on any one of these and see.
No, the thing is that the scientists talking about this.
Look,
they also
look, here they all are. Okay, Miocene. I mean, these are old, so we want to go to more recent ones. Okay, let's go to the Upper Paleolithic. Okay, there's loads of them. Okay, loads and loads of them. They're not just Homo sapiens. Well, we can go earlier. We can go to Australopithecus. We can go to Ardipithecus. We can go, we can go to loads and loads of different hominid
How do you know that they were not human and they were not?
Okay, well you can look at the specimens yourself. Go to the Science Museum. Look at the specimens yourself.
I know that. I didn't refute that in the same species, within a species,
No, but
we can have
isn't.
evolution.
Australopithecus is not human, is it? Do you think Australopithecus?
No,
is
tell
human?
me why with the bones can we say that it wasn't human?
You see, okay, you plot hominid skull size over time. Okay, if evolution is true, you should see this progression. Okay, so let's do that. Let's look at hominid size, hominid skull size over time. Right? Let's do that.
Because we can have fossils, I don't deny it, but within the same species. We cannot say,
No,
it
but
evolves.
Okay, you don't see hominid skulls. You don't see that projection. If it was just another small human, there's no reason to have this straight line, is there? Right? Let me show you the plot. I have to find it first, so give me a moment.
At that time, it was an adaptation, and that
Okay, this is a plot of hominid skull size. Okay? What do you see? Tell me which direction is it going in?
I'm just asking you.
What is going on here?
Yeah,
Tell me what's happening.
You can see that there is an increase.
Okay. Now, if humans had just always been there's no reason for that line to be going up. That would only be true if evolution was true. Okay? That is the direction that we should expect if evolution is true, and that is precisely what we find.
My problem with that, I'm just going to answer.
Okay.
This, you cannot say that there we have species and not here there. We can have a variation of volume with within our skulls in the same species.
Yes, but
you can have two species.
No. I'll tell you why your logic's wrong. Yes, you can have small people.
Yeah.
You could have children.
Yeah.
Absolutely. But when you get fossils are very hard to form. If you know how fossils form, it's very difficult for them to form.
Yeah.
Okay, so it's very rare that a fossil is formed. So you're getting a sample of a population. Okay, now if it was there's no reason. Okay, you're randomly sampling from a population. Okay, so if your population is changing,
this is what you find. It's not randomly. You took what you find. You take what you find.
Okay. When you find, no.
Look in the heat.
Yeah, but you're completely misunderstanding what the theory is saying, right? If you're randomly sampling from these populations, okay? So if evolution is true, then what we should find is that those skull size should be getting smaller. And that is, as we go backwards in time, that is precisely what we found. Now, if it was just a small person, there's no reason why you wouldn't also find big people's heads. Right? Do you see? You would find big people's heads just as you would find small people's heads, because old people die as well, right? So there's no reason. If it's just we randomly found small people, there's no reason to see this trend. But if evolution is occurring, then there is a reason to see that trend. So there's a clear prediction from what you should find in a fossil record from evolution, and that is precisely what you find.
So and
it also matches the molecular clock evidence. Okay, molecular clock. So we have sort of rough rates of mutations. Okay, so roughly every generation has about 100, 150 mutations. Okay, so you can use that to do what's called molecular clock dating to work out when these splits can occur, and you can match that to what you find in the fossil records, and it matches.
The problem is how many do we have? How many fossils do we have of same area?
I don't know the number of fossils.
Okay, so you're just telling me we find something in one area, we find 2 or 3, and then we say, that's it.
It's more than 2 or 3. It's more than 2 or 3. I can assure you that. Sure? I've been to different museums and seen them.
The number of fossils is really limited. It's not a huge number.
It's not, okay, no, I agree, it's not a huge number. But there's no reason for that trend to be there if evolution was not true. Give me a reason.
Now you change your assertion. You tell me it doesn't prove that evolution is false.
Okay, no, I didn't change my assertion. Okay. My assertion is clear.
What?
The theory must make predictions for data that we find. If the data comes back and matches what the theory says, then we provisionally say that theory is true. Okay?
It's based, as for the Big Bang, it's based on assertion. Okay? Yeah. It's based on assertion and conclusion.
Yeah.
We suppose, we observe, and we conclude.
Yes, of course.
The problem is the conclusion. I said with the observation we have and all the materials we have, you cannot conclude. You can just say, okay, we find this and that's it.
Well, again, it's like anything. It's not a small number. There is a large number of predictions that the theory makes. Large number.
Putting the mutation aside. Putting the mutation aside within the same species. This is, if you have not another.
Okay. I mean, you're arguing against predictions that you're not even aware of.
No, I know.
Right?
No,
you don't know what these predictions are, do you?
I know what is prediction.
No. You don't know what the predictions are of evolutionary theory. Is that a fair comment?
Okay.
Because you didn't know about the telomere fusion, did you?
No, I don't know everything.
You didn't know about the GLO, GULO.
No, doesn't mean that I have to know everything.
But if you're going to diss a scientific theory that's accepted by the vast majority of serious scientists, you should at least be familiar with what the theory says and predicts.
No,
is that not fair?
No. The problem here is that serious scientist. This is you decide who is.
No, I don't. There are ways that you can assess what is serious science and what is not serious science. And the way we do that, if you actually knew anything at all about science, you knew there are ways to do this. Okay? So journals.
Okay, I'm going.
Not today. It's too hot. Too hot.
Just
yeah.
It's too hot. We didn't find any. There's a bus. We didn't find it. We should. What we should do is, I'll talk to a bus because a bus is
name became Muslim.
Well, doing fun things. Yeah, shouting at people.
Let Rob know when you're coming down next year.
If you want to sort like a football way to some
This is fair. A bus will probably like it.
Yeah,
but then when I find them, I'll let you know.
Okay.
Hey, we're not going to do that. We don't do that. How's he going to do any breakdancing if he's online? Let me know when he's coming down next. It'll be good to see you, okay, bro?
Just can I ask one?
Yeah, Phil, go ahead.
It's been on my mind since we've been talking about evolution. He was saying that, I think he made a point about there not being enough time for random mutation and natural selection to account for all of it. I would fully accept evolution myself and I don't have any theistic bias, but I might be tempted to agree with that, not scientifically, but as a layman, seeing things that I've read, seems to be like those two things themselves might possibly not be enough. There might be other things.
Well, I mean, first off, in evolutionary theory today, it's not just random mutation and natural selection. There are other elements like genetic drift.
Yeah.
Okay, so it's not just that. Okay, but I would go back to the point that these calculations of how likely it is, those are extremely, they're not accepted calculations. So the simplest explanation is, go and read the literature, okay?
The problem, you rely on some person and they just don't
But you're
accept.
relying on that calculation being true, aren't you?
That calculation is mathematics. It's from mathematics.
No, but all mathematics, if you're going to apply it to the real world, has to have physical assumptions, okay, about the way these things behave. No, it's not false.
But,
you can't.
okay, for
of course
probability, you can accept. Do you believe that at the beginning we didn't have any proteins? Do you believe it?
I agree, yeah.
You agree? Okay. So you believe that it has been formed randomly? Randomly?
Not necessarily just randomly, no. There may be non-random processes.
How does it form?
There may be non-random processes. I don't know how proteins form. But you make the assumption.
No,
you make the assumption that the probability of proteins forming is X, and that is an unverified claim.
No.
Okay? That is not accepted science.
No.
You're making it out to be a fact, and it isn't.
No. Your reasoning is blurred because you told me that I don't know the process, but it happens. It means that in your brain you have accepted that something happened. We don't know, but it happened, and it's not probabilistic.
But I am not an expert on the way proteins form in the early Earth. Okay? So I'm not going to make a declaration as to what the probability is because I'm not an expert in that. Okay?
So
but you've read one thing and you believe it. Okay?
No, just typically, generally in the evolution theory. Just typically, what I know is that the number of fossils are not enough. We have just
you know
few
that,
amounts.
do you?
I know.
Based on what?
So, do you have a huge number? Am I false?
Well, what do you mean by a huge number? Tell me what is a huge number.
A huge number, a huge sample.
Okay. First off, I don't think you need a huge number. What you need is for the theory to be able to predict where fossils are located. And that is exactly what happens. So let me give you an example, right? Do you know what tiktaalik is?
Tiktaalik?
Yeah.
Okay, tell me in English.
Okay, again, you're talking it's an incredibly famous transitional fossil and you've never heard of it. So if you're going to tell me that we don't have the transitional fossils and you're not even aware of the transitional fossils.
Telling me in English, I'm translating.
Tiktaalik. It's not an English name, it's a Latin name because it's a scientific name. It's not English or French. It's tiktaalik. Go on Wikipedia and look up tiktaalik.
Okay, tell me.
Tiktaalik is a transitional fossil between fish species and land species. It has transitional forms between the two. Now, it's not just that we found that fossil. That's not the point, although that is a very strong piece of evidence. It's that evolutionary theory was used to predict where the fossil would be found, because it's very hard. There it is, Tiktaalik fossil, okay? Like you can't be serious debater here.
No,
if you're going to say we don't have the fossils and we do have them and you've never heard of them, but seriously,
I've heard that they were.
That is not okay.
The problem is, look,
okay.
I don't know the names, but I've heard of it. The transition from the sea, from the sea to the earth. I've heard of it.
No. But what you haven't heard of is the fact that evolutionary theory was used to predict where these fossils would be found.
You will not find it in the sky. You will not find it in the sky. You just, where will you find it? Okay, tell me where.
Okay, you're missing the point. You're missing the point entirely.
Tell me.
Okay, I will. Right. So it had to happen within a certain time period.
Okay.
Okay. Now, so you can use evolutionary trees to work out when this time period would be. Now, obviously you're not just digging randomly in the ground. You're not going to find anything that way. Okay. That's not what paleontologists do. Mm-hmm. Okay. There are certain layers, certain sedimentary layers that will be relevant to certain time periods. Okay. So, if evolutionary theory was right, then these transitional fossils will be found in particular layers. Okay, and there are certain locations where it was known that those layers were exposed, where they were accessible.
What was the assertion? What was the assertion? The prediction? What was the prediction?
The prediction was that transitional fossils between land animals and fish would be found or that they would have certain characteristics found in certain layers in the rocks. Okay, so it could not be located in, let's say, the KT boundary layer. That's too late. Okay.
50 million years.
Yeah. Okay. So if you add in the KT boundary, that's too late.
Why?
So the theory, because it's too late. It's too recent. It has to be earlier because we've already got land animals by the KT boundary, haven't we? So it couldn't be then, could it?
I mean, right?
Tell me. Right, so it has to be at certain locations where certain sedimentary rocks are exposed, where certain transitions are. Okay, it has to be there. And guess what? They dug there and they found them.
Okay, so you told me because we didn't find.
If you're just going to dig randomly in the earth, you're not going to find it. Yeah.
You just told me that because in the layer below we didn't find any big animals. They predicted that just above.
It's not just that. I'm summarising. If you want to read a book on this, why don't you read a book that says it's called Your Inner Fish by Neil Shubin. He was one of the guys on the team.
No.
He found this fossil.
So you're just telling me
there's more detail than that. I'm giving you the short version.
Generally, just tell me that we took the lower because we found that. Okay.
If you imagine this, the sedimentary layers, okay? But beneath here, right, beneath this belt, you only find marine animals, okay? If you look here, you find land animals. You don't find land animals down here. You only find marine animals. So if you're looking for the transitional forms, it has to be here. Okay. Can't be down here. Can't be up here. It has to be here. Okay.
1 million years before the first tetrapods.
Right.
About 360 million years ago.
So they then said, okay, where on the Earth are rocks from this time period exposed that we can access? Okay. And there are and in the Canadian Arctic, there are locations where you can access rocks from these time periods.
But we didn't find animals.
We found the transitional animal Tiktaalik. It has exactly transitional forms between land animals and between fish. And then you can tell this, there are many ways you can tell this. For example, when you go through the evolutionary fossil record, you find the location of the inner areas moving, okay? So then you can predict where it should be in this fossil, okay? So when you dig up the fossil, it's precisely there where the theory predicted it would be.
Okay. So just asking you, can we know? Okay, in this assertion, where is the proof to the random mutation?
It's nothing to do with that. The whole point of this.
No, but you think evolution it is caused by mutation?
Well, yes, but you're missing the point. You're missing the point. If evolution is true, there are certain things that we must discover. Okay. So
No.
if evolution was false, for example, if we found right at the most oldest layer, modern humans,
Okay.
then evolution is false. Okay? If evolution is true, then we find things like this. Okay? And so we make predictions for what we should find and where we should find them, and the data precisely matches what the theory says.
Okay. Just a scientific question.
Yeah.
Before, okay, according to before the atmosphere, the atmosphere wasn't. We cannot breathe in this atmosphere
Correct.
at that time.
There was no oxygen.
Okay.
No, that was earlier. That was much earlier.
Much earlier.
That was earlier. That was much earlier.
Much more when?
Oh, that would be the first few hundred million years of the Earth. When oxygen formed, I don't know.
No. When the atmosphere, when the creature were able to breathe.
Breathe air breathing animals.
Yeah.
It'd probably be around about this sort of time.
That's story. Okay.
It's about that sort of time.
But before, okay.
I don't know the exact date off the top of my head.
Okay.
No, but
The problem
it's gonna
is
be-
there is another part. You said that there is the random. Okay, I don't reject the selection. I know that you talk about two things. There's the random mutation.
Well, actually, there's more than two things. There's more than that.
But
There's
I'm just
genetic
telling him. Let's talk about the random mutation. Do you agree that in that case we would have a large amounts of species who died and were deformed, several forms?
Not necessarily, no.
So, do you believe that
No.
we got the good mutation in the exactly good?
When you say we have them, do you mean like as fossils?
No, I mean the
What do you
animals.
mean?
You believe that they were evolution, okay?
Oh, well, first of all, most mutations are not dangerous. They're not bad for you. Most mutations are neutral. They don't do
But
anything.
most
Mutations are neutral. They don't do anything. Yeah.
It means our corpse is in a line. It means if you change a little bit a thing in our corpse, we could die.
In our corpse.
I mean,
So a corpse is a dead body. Sorry, maybe you're
biologically,
okay.
if you change
Yeah.
something, according to your selection, there is a huge probability that you will die.
No, that's false.
Why?
Because most mutations don't do anything. Most of your how many genes do you have? Do you know how many genes we have?
That's pretty interesting. Okay, most doesn't
mutations.
affect.
Yeah.
Okay, that's interesting.
Yeah.
So what about the others? We change function.
Yeah,
Because
sure,
it's about
Agreed.
us.
Yeah, I agree. Okay, then for those that do change, more do damage than do good.
Okay, so the probability to damage us is much more huge than having a good evolution.
I agree. Yeah. I agree
Okay,
with that.
so I'm just telling you what confirmed this part? What confirmed this part?
Well, genetic experiments confirm that. You can
telling me that the
do
probability.
mutations. Yeah.
You tell me that the probability of having damage on the corpse, on the genes, means the probability to have damage with a mutation which change us, the mutation which change us,
Okay. Yeah.
or much more bigger
Yes.
than the one which suit to us.
Yes. So what? What's the
Okay,
problem?
so the problem is if we are rational, we would conclude that normally we would have a large quantity of fossils, which shows us that this evolution.
No, that's wrong.
Why?
That's wrong.
Why?
Okay, I'll show you why. I'll show you why.
You can say that evolution happened by all the things that he said. The mechanism by which it happened seems to me to be incomplete at the moment, because I don't think
Okay.
people know.
Your point is wrong. Let me try and explain why your point is wrong.
Why?
The main reason why your point is wrong is because of something I said before. It's very rare to get a fossil. Fossils don't just happen like that. Okay, let me finish. Let me finish the point, right? Therefore, if you have some animal that gets a mutation that's dangerous to it, that makes it doesn't survive, it's very unlikely to fossilize, because in order to get a fossil, you have to have a population. Okay? In order to get a population, you have to have a beneficial mutation. Okay? So you're not likely to get fossils of the animals with one eye when they should have two, or 3 legs when they should have 4. That's not what you're going to see as fossils. What you're going to see as fossils, what the theory of evolution predicts you should see, is not that, because of the reason that it's very rare to get a fossil. What you should see in the fossil record is increasing complexity over time and certain trends like we discussed with Tiktaalik. So for example, if you look at the oldest fossils, you don't see complex animals. Okay, the oldest fossils are very, very simple life forms. Okay, that is exactly, yes they are. Yes they are.
They came out of the sea and they just stuck on the...
Well, marine animals are certainly older than land animals.
It's
and
really
that's another
complex.
thing. No, you're wrong.
Okay, they don't have a brain.
Correct.
They don't have brain.
Correct.
They have.
Correct. They don't.
They don't have a brain.
No.
So how do they?
Well, jellyfish don't have brains today. And they seem to do okay, don't they?
So they don't have neurobrain, any neurotransmission.
They
What
have
guides them? What
reflection.
guides them? What guides
well,
them?
they don't have a brain, okay? They have very, very simple... You can look up the anatomy of a jellyfish. You won't
So
find
they
a
don't
brain.
have instinct.
They have basic chemical reactions that move them around. They don't have brains. There's no brain in a jellyfish, is there?
Generally, it's not. We're not talking about brain as like us.
There's no
We're
brain
talking
in a
about-
jellyfish.
We're just talking
There might
about.
be some very patch of neurons, small, simple patches of neurons.
We have neurons.
it's not a
we have
brain.
neurons. Okay, they have neurons. Okay.
They might have a very
But
small,
it's
simple
complex.
patch.
It's still complex.
It's less complex than us, isn't it?
Of course. Of
Right.
course.
So what
but
I'm
it's
saying
complex
is,
than nothing.
if you go back, obviously you have some level of complexity. You won't fossilize if you don't, right?
Filming our feet.
No, I don't want to be filmed. I don't want to be filmed.
If you've got no complexity at all, you're
he's
not
just
going to
listening.
fossilize, are you?
Or he's just listening.
What you're missing is there's
No,
a selection
you're filming
bias
my
in your
legs.
data.
No.
If you have no complexity, you're not going to fossilize.
I know.
So it has to have a minimum level
No,
of complexity to fossilize.
this is
doesn't it?
interesting because you're just taking the subject upside down. I told you from the beginning that you're taking some experience on mutation and you're generalizing, confirming this random mutation. I told you that if it was true, if we had several mutations, you admitted that the number of fossils who died by deformity, by damage caused by mutation, would be much, 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 much more bigger
Yes, agreed.
than the
mean greater in number?
Right.
No, yeah, in number,
Yes.
than the good fossils caused by mutation. And you told me, yes, but you cannot check my assumption because it's really, it's not common to have a fossil. So I told you, how can you affirm that it was a mutation which caused, how can you affirm that we had several mutations which caused this?
Okay, the way you confirm what mutations do is you can do genetic experiments in a
No,
lab.
genetically
Right.
mutation exists.
Right.
But saying that we had a lot, and then one was better than the other, and again and again.
Again.
How
Right,
can you prove this?
Okay.
When you say that we don't have a lot of fossils,
No, I didn't say we don't have a lot of fossils. You're putting words in my mouth, right? You have to define what you mean by a lot to start with, right?
Okay.
No, we have enough
Many species
fossils.
appear together, not successively. They all appear together.
That's
no?
not true.
Oh,
That's
really?
false. That's completely false.
Just how can you confirm that there were lots of mutation, a billion died,
Okay.
but just one.
What you do is you look at a theory in its entirety, and you look at the predictions that the theory makes.
No,
This is the point that you're missing entirely. This is the point that you completely fail to understand basic principles of science. The basic principles of how we assess theories is that they make predictions, specific numerical predictions, and then we go and we look at data and we see, does the data match the theory?
The problem is you gathered both mutation, I don't deny it. Sorry, because I'm just maybe mutation, I don't deny it.
Okay.
But when I talked about having a lot of mutation, making a billion of dead species, and then the good one appeared, and again and again. Just
you're missing the point.
Okay.
Okay.
Give me the proof for that.
Okay. First off, we don't talk about proof in science, so yet again, another misunderstanding, right? Let me finish. Let me finish. Okay.
Trying to catch the point.
Yeah. First off, I mean, you don't even understand basic science. First off, we don't talk about proof. We look for evidence. We look for theory confirmation. Okay. Now, to come to your point about the dead ancestors, it makes no difference. You're hanging up on a point that's irrelevant. The relevant point is that beneficial mutations spread through a population. Okay, that is a relevant point. It doesn't matter. It makes no difference how many dead bad mutations there were. There could be a few, there could be a lot. It makes no difference. The theory doesn't hinge on that. Okay, what the theory hinges on is that the beneficial mutations spread through the population. Okay, and we can test that with lots of studies that you can do in loads of populations. You see how positive mutations spread through a population. There are loads of field studies to check that. Okay. Then, if we want to know about ancient past, we can do a number of things. There are a number of things we can check. We can check the fossil records. We can check the genetic records, because inside your gene, you know that you could do a genetic test to find out who your parents are, right? Do you know that?
Yeah.
Would you accept the results of that test if they came out?
I think that they are my parents.
Why wouldn't they?
Right, okay, you agree it's a reliable technology?
I agree.
Would you agree it's a reliable technology? Okay? Well, we can do the same for your grandparents, and back and back and back, right? And when we do those genetic tests, what we find is that we share common ancestry with other species, okay? That common ancestry has predictions for what we find in the genome, like the telomere fusion that I told you about. I'll give you another example. There are endogenous retroviruses inside your genes. Okay, these are viruses that are deactivated, but they're inside your genetic code, i.e. they get passed down from ancestor to descendant. Okay, now these ERVs are randomly located inside the genome. Okay, so we can look at other species and find out where their ERVs are. Okay, and if the theory makes them predictions for where these ERVs should be, and when we go through the genome and we look through it, we find that it's exactly in the location that the theory says they should be. Okay, now if you think that evolution didn't happen, then you've got to claim that this is pure coincidence.
No.
Then how do you explain it?
I explained that we have genes in common with every creature.
That's not the point. That's not the point I made. The point was the location of the endogenous retroviruses within the genome matches the theory of evolution. It matches what the theory says, and that you don't have any other explanation for that.
So for you, this experience proof.
We don't use the word proof in science. It is evidence. Okay, proof is only in mathematics.
Okay, so just a question for you. The thing is, why? I'm just going to give you my point on mutation and evolution.
Okay.
It means you have one species. I don't deny that you can have nails. Okay, let's say.
You said that already. Let's not go over the same stuff again.
How do you prove that it comes out of this?
I've just told you. I'm not going to go over it again and again and again. I'm sorry.
No.
I think I'm going to be done here, because you're asking me how do we prove it, and I've given you how we prove it, and then you ask me how we prove it. I'm sorry. I'm not prepared to just go over the same thing. Can I make one suggestion? There is a book. He's written by a theist. He's not an atheist. He's a theist. He goes over the many predictions of human and chimp evolution. Okay. The book is called Relics of Eden. Do you have a phone?
Yeah.
Why don't you read the book? It will go over what the evidence is.
Tell me.
Relics of Eden, the book is called. I think it's Fairbanks, I think is the name. And it goes over what the very specific genetic predictions are. Okay? I showed you that thing, but there's reasons why they had that conclusion. Okay? Relics of Eden. Go on Google Relics of Eden and I'll find you the author. Relics of Eden. Relics of Eden. Yeah, human evolution. Okay, we'll get this book, Relics of Eden. Can you put this into your Google? Yeah, that book. Get that book. And then we'll go over it in great detail.
Knowledge of
To be honest, evolution is not my field. More cosmology. So if you have questions about the Big Bang and things like that, I could try and answer those.
So who triggers